Good day, everyone, parents and students. I am Olumide Famuriwa, an online science tutor and the lead tutor at Lyceum Academy, Nigeria. In today's video, I'm going to be providing solution to one of the greatest challenges being encountered by chemistry students globally, which is balancing of chemical equation or reaction. To do this, we are going to be solving together the question on the screen, on the board rather. This question came out in GCSE Chemistry organized by AQA. Aluminium is extracted by electrolyzing molten aluminium oxide. Balance the equation for the reaction. Choose numbers from the box, meaning we are picking numbers from this box to fill in the gaps that we have here. I need to rub off this side, so let me quickly give you a few seconds to copy the question. 1, 2, 3, 4, 5, 6, 7. Okay. Thank you. So the first step in solving this question is to remember the law of conservation of mass or matter, which states that matter can neither be created nor destroyed, but it can be converted or transformed from one form into another. The meaning of that is very simple. It means the number of atoms on the left-hand side of our equation must be equal to the number of atoms on the right-hand side of the equation. So, if you look at this compound, aluminium oxide, what are the elements we have here? We have aluminium and oxygen. So, I'm going to write number of atoms of aluminium, I'm using the symbol Al, number of atoms of aluminium on the LHS, meaning left hand side, is equal to coefficient number multiplied by subscript number. The same thing is applicable to oxygen. Number of atoms of oxygen, I'm using the symbol, on the left hand side of the equation is equal to coefficient number multiplied by subscript number. What does that mean? The word coefficient number means the number that is written before an element or before a compound. In this case, this is the number that is written before this compound, aluminium oxide. So our coefficient number is what? Is 2. So for aluminium, I'm going to have 2 multiplied by, what is the subscript number? Subscript number is any number that is written at the base of an element. In the case of aluminium, the base number that is written here is what? Is 2. So we substitute 2 here. That is 2 times 2, which is equal to what? 4. Meaning the number of atoms of aluminium on the left-hand side is equal to what? 4. We'll replicate the same process for oxygen. Now, what is the coefficient number for oxygen? The number at the front, which is what? Which is 2 multiplied by, what is the subscript number of oxygen? It is 3, this base number here. 2 times 3, and that gives us what? 6. So we have 6 atoms of oxygen on the left-hand side of the equation, and we have 4 atoms of aluminium on the left-hand side of the equation. Now, to drive home our points now, we can now do the mathematics again. This is aluminium, this is 2 that is written here. 2 times 2, 4. Meaning the number of atoms of aluminium on the left hand side is 4. So we come to this place and write 4. So this is the first option that is correct for aluminium. So 4 aluminium atoms are on the left hand side and we have 4 aluminum on the right hand side. Now, we do the same thing for oxygen. Going by our calculation, we have gotten the number of atoms for oxygen on the left hand side as 6. Now, if we put that 6 in this bracket, does that make any sense? Don't forget that we are going to multiply the base number here, which is the subscript, together with the coefficient number. 2 times 6, that gives us what? 12, right? But do we have 12 atoms of oxygen on the left hand side? No, we have 6 atoms of oxygen. That means we cannot put 6 here. All right? Now, let's look at the remaining options we are given in the box. Can we put 2 inside that bracket? Can we put 2 in the space here? Let's see. 2 times 2 gives what? 4. Do we have 4 oxygen atoms on the left hand side? No, we have 6. So 2 is what? Is wrong. We can't put 2 here. Let's look at the next number. Can we put 5? All right? At the space we have here, or in the space we have here rather. So 2 times 5 gives what? 10. Isn't it? And the number of oxygen atoms on the left hand side is what? Is 6. So 10 is not what? Is not correct. So we erase this 5. So 5 is equally wrong. The only number that is left in this box is what? 3. If we put 3 in this space, let's see if we are going to have 6 atoms. 2 times 3 gives what? 6. Meaning we have 6 atoms of oxygen on the right hand side, just as we have 6 atoms of oxygen on the left hand side of the equation. As you can see, the equation is balanced. The approach I have used here is called try and error method. One of the challenges about try and error method is that it consumes a lot of time. And for many starters, people who are just starting chemistry in life, students who are just starting chemistry in their life, it can be very, very frustrating while trying to use try and error method. How do you then overcome this challenge? To do that, I'm going to be teaching you in my next video an alternative method of balancing chemical equation. This approach is simple, easy, and straightforward. Okay? Now, if you have enjoyed this video, please drop a comment for us, share this video, like this video, and follow us on various social media platforms. If you want to enroll your children at Lyceum Academy Nigeria, please reach out to us via WhatsApp number being shown on your screen. Until some other time, when I will be coming your way again, please keep balancing various equations in your life. Thank you. Cheers.